Hello world viewers, what's up? I hope all you are doing well and your nears and dears are also doing well. Sorry for the late of this video due to some reasons. Because I have two channels also I have regulated, that is Odia channel also I have regulated, and there is also another channel I have the fashion about music also. That's why the late of this video. What about the late? Have you watched the previous videos or not? Then go and watch about relativity. Okay, so good morning to those who are watching in the morning, good evening to those who are watching in the evening, and good night to those who are watching in the night. So here I am today discuss about very fantastic, personalities. Who is James Clerk Maxwell? You are using the communication system today. You are using mobile, laptops, tablets, everything. The gadgets are there. But the main communication system, the origination comes when there is the term electromagnetic field theory. Electromagnetic field theory plays a major role. It's simple. Electromagnetic field. We have listened, it not listened. Definitely, we have listened, and there is a person behind that. That is Maxwell, James Clerk Maxwell. Okay, so he has designed that theory in 1864. 1864. In today's videos, we are discussing about the four equations which he have generated on that, and also next videos we are going about the derivations. Okay, we are just seeing today's what are the differential and integral form of the Maxwell 4 equation. Okay, so in this video we are doing, because for that equation so we can generate this kind of devices everywhere from your side or their side or whatever side. Okay, so what are the Maxwell 4 equation? Maxwell 4 equation. So these subjects are basically in the graduation subjects, and also those who are doing engineering, there is also a subject they can connect it more. And if you have any particular university, they can provide me that syllabus and I will make those kind of videos according to that. Okay, so it's about that intro section I told about. So what are the four equations we'll do, and he generated this theory in 1864. And when we come to the electricity and magnetism, both electromagnetism means electricity and magnetism. We all know if there is electricity, there is magnetism. If there is flow of current in the conductor, that means it also create magnetic field at the same time. If electricity flows, that means electric field generated. If the electric field generated, the surroundings magnetic field also generated. The angle between them is 90 degree. We all know about it. Okay, so not to worry, if there is magnetic field, there is electric field. Okay, so what are the four equations? We'll know what are the terminology that is new to you, right? So we'll discuss all the terminology, all the symbolization, what we call in the symbolization, we'll know it. And I will make the playlist of this video. Okay, electromagnetic field theory. This is the first video I will do. Okay, so what is the first equation? Divergence of D. Divergence of D is equal to rho. Is equal to rho. We'll discuss about what is D, what is divergence, what is rho. We'll discuss about that. Okay, don't be worried. The second equation is divergence of B is equal to 0. Divergence of B is equal to, okay. So the third equation is curl of E, that's equal to minus diver B upon diver T. Okay, the fourth equation is curl of H, that's equal to J plus diver D upon diver T. So these are the fourth equations. Okay, I will discuss about what is divergence, what is this kind of things, and what is rho, what is B, what is E, what is T. So these are the four equations. Okay, we'll discuss what are the terms and how it forms. Okay, so first case I say divergence. So when there is a symbol of delta with a dot, it's called the divergence. Okay, it calls the divergence. Okay, when it calls call. Okay, when the delta is with a cross, that call. Okay, so it is the divergence, it is the call. And next third step, when the only delta is there is nothing, only this is fixed out, that means it is called the gradient. The multiplication with it, but the multiplication with isn't seen, so it is called, what is it? It is called gradient. So these terms will discuss in the mathematics section. So just to learn here that these are called like this. Okay, so in this state these are the completed things. So we'll discuss what is D, what is P. So D is basically the displacement density. It is called displacement density. Displacement density. So what is displacement density? It is about how much displacement happened. Okay, in case in other books you can also find that D is symbolized as E. Due to some reason, D is actually directly proportional to E. Directly proportional to E. That means when we equals this, though this is epsilon naught E. So the both are directly proportional. The electric field and the D is directly proportional. That's why sometimes if E naught is 1, I mean epsilon naught is 1, that means D is equal to E. So in some books there is V, I mean divergence of D, divergence of E also sometimes it written. So don't to be worried about that symbolization, right? So these D and E are both are equal, we can say. Then the rho, you know what is rho? Rho is about okay, rho is your density, you know. Rho is symbolized as density. It is the density. Okay, so here the B is here. B, we all know B is called the magnetic field. It is called magnetic field. Okay, so this is the B. Okay, so when it comes to call of E, E is here electric field. E is here electric field. Okay, so it is minus of divergence of B upon divergence of T. Why there is minus sign? We'll discuss it due to the Lenz's law also happening. So Lenz's law. Okay, Lenz's law. We'll know it. Lenz's law. Okay, in the other videos. So it is due to that the minus sign is there. B is the magnetic field here also. So here H is the electromagnetic induction. Magnetic induction. Okay, so H is the electromagnetic induction and J is the current density. What is current density? Current is flowing for unit area. What amount of current is flowing for unit area, that's known as the current density. And J is there is a formula for J, that is equal to I upon H. I mean for unit area how much current is flowing. Okay, that's known as the current density. And there is also divert D upon divert T, that is the displacement current. Divert D upon divert T. You say displacement current, it is a new thing, you know, it is a new thing, displacement current. Actually only J will be happen if there is a Henry law. If the H electromagnetic induction is there, then why this addition happened? Actually what happened in case of when it go to the transformer, you know, so there is the displacement current. I mean there is a displacement current divert D upon divert T. Okay, what is displacement current happens when you show a capacitor, you know, there is a capacitor, you know it, there is a capacitor, this is the capacitor. In the mid terms, let's say this is the A and this is the B and A and B and the in middle we fix a dielectric. We fix a dielectric here. Dielectric material, we know it. So there is no direct connection between this and this. Still the current flowed. Still the current is flowing. How? Due to the displacement current happening. Okay, so this is actually the things that's additional happen. The Maxwell add this kind of theory. That's why it's called the modified electromagnetic induction. That's why it is also called modified electromagnetic induction theory. Okay, so this is the fourth equation, that's when a capacitor is not fixed, there is in between there is dielectric, still the currents are passing. Okay, so these are the four scenario, these are the four equation we are doing, and in the next state we will discuss about on which principle these are based upon, on which laws, which theories, which principle these four laws are going on. We'll discuss in the next stage. Okay, so we'll discuss it. Okay, so I'll erase it. Okay, not to worry about the notes. I'll provide all the notes in the WhatsApp channel. If you join the WhatsApp channel, there is crowd, then I will provide all the notes. They're ready with the notes with me, right? It is about to you to join that channel. So it is your responsibility, you can say. You have to join that channel. Okay, so the first law, first equation, that the divergence of D is equal to rho. Divergence of D is equal to rho. Sorry, rho is volume charge density. Volume charge density. Okay, so the first equation is working on a very well-known principle, that is Gauss law for electrostatic. Gauss law, we know Gauss law, we'll discuss it. Gauss law for electrostatic. Okay, static. Then the second equation is going on Gauss law for magnetostatic. Okay, the third equation is going on the Faraday law. You know, that is the Faraday law principle. Faraday law. And the fourth equation is going on modified Ampere's circuital law. So these are the four equations. First is Gauss law for the electrostatic, second Gauss law for the magnetostatic, and third is the Faraday law, and fourth is the modified Ampere's circuital law. Why modified term is happened? Because the displacement current is added with the current density. That's why modified word used here, due to Maxwell, actually James Clerk Maxwell. Okay, so in the next state we will discuss about what is Gauss law, what is Gauss law for magnetostatic. Okay, so firstly I will discuss about the Gauss law. What is happening with the Gauss law? First state. Okay, I just did this. So the first equation is going on the principle, that is Gauss law. So we'll know what is Gauss law. We have read it from class 11th and 12th, that Gauss law. What is happening? Gauss law, that is surface integral of E dot ds is equal to Q upon epsilon naught. The surface, I am not telling about those statement. I'm just representing in the equation. That's I like the most. I don't like the critical definitions. I always like the equations. That's why that is surface integral of E dot ds. I mean, in that particular area, how much electricity is passed through. In that particular area, suppose this is a particular area, how much electricity is passed through. This is electric field. Electric field means electricity is going on. That's called the electricity. So what is that value? That is Q upon epsilon naught. Q is the charge. Okay, Q is the charge. That is the Gauss law principle at first state. In the second state, divergence of B means magnetic field. Let's say there is a closed surface. Let's say this is the closed surface. Okay, and something is going on, and pipe magnetic field is going on, and what happened here? All the pipes are passed through. That means there is no remains inside that. All the pipes are going and they are coming and going. That means the divergence of the divergence of the magnetic field, that is equal to 0. That is equal to O. That's why it is the two principle. We have discussed that Gauss law in the electrostatic and Gauss law in the magnetostatic. There is no divergence, that means that is O. So the divergence of V is O. 0. The pronunciation of 0 is sometimes called O. In the Western, if you go to American sides pronunciation, then 0 is called O. Okay, that's why I tell it. And the third equation is going on that principle, that third equation is Faraday law. We know Faraday law. And the third equation, Faraday law. Or we can say that is two laws of Faraday. We can say electromagnetic mutual induction. Electromagnetic mutual induction. So there is a relation. There is electric flux. There is term electric flux. It is called flux. It is magnetic flux. If the B is there, it is called magnetic flux. If there is no symbol, then there is E. That means that is electric flux. If the symbolisms are there, so then it is very much easy for us. Okay, what happens when a transformer? Let's say there is a transformer. There is a AC source is connected here, and this is the coil. Okay, so here, and this is the coil. Okay, so this is a transformer system that figure out. The rest I just reach. So what happens when there is a difference in the flux? So let's say there is something of current 10 volt is generated here, and that output also 10 volt. Also that means or 11 volt or 12 volt, whatever the same voltage of if going on. I mean to say, if the electric flux happen when there is the change in, when there is a change in the flux. If there is a change in the flux, that means there is EMF generated. What? EMF, electromotive force. If there is change in the flux, if there is change in the flux happened, that means EMF generated. Let's say it is 11 volt or 12 volt, it passing through, whatever. If there is difference, then EMF generated. And what is the formula for EMF? That's equal to minus of d phi v upon dt, divert phi v upon divert t, or it is simply a differentiation, we can say. So what's the formula for it? That's EMF is equal to EMF. If there is change in the flux happen, that means EMF is equal to minus of differentiation of magnetic flux upon time. I mean to say differentiation of magnetic flux with respect to time. So it is the EMF if there is the change in the flux happened. Okay, so what is the actual Faraday's laws? We will discuss here that linear integral of E, linear integral E dot dl, that's equal to surface integral of B dot ds. Okay, so this is the law. I mean to say, this is the law about electromagnetic mutual induction. Okay, so this is the actual law. For this we have to understand these kind of things. What is phi v, that is the magnetic flux. So these are things happen. We have discussed about the EMF. Okay, so what is the actual formula is that, I mean to say, what is the law electromagnetic mutual induction? That is the linear integration of E dot dl is equal to d upon dt. Sorry, I forgot that minus d upon dt, that's equal to surface integral of B dot ds. Okay, so this is the actual law about electromagnetic mutual induction. Okay, so in case of why the minus symbolization happened, due to it is the negative flux happen. Okay, that's why the minus symbolization, and that negative flux that also happened in the Lenz's law. This is the Lenz's law actually. Why the minus symbolization? Because the negative flux happened. That negative sign is symbolized, that is happening in the Lenz's law. So all the laws are in the simple question. That is the, I say, Maxwell is that ultimate power. In the 1864, someone is thinking like this. Look at that. That is the modernity. It's all about that in case of Einstein. Okay, so in the era of Einstein, before Einstein, Maxwell existed, right? Without Maxwell, I can't even think about E is equal to mc square. I always tell it. And look at the equations. Okay, and the fourth equation is that the curl of the edge, right? Your h is the, okay, curl of the edge is equal to electromagnetic induction. Okay, h is the electromagnetic induction. Okay, so what happens here? Current density plus displacement, and we have discussed it in the previous section. What is the displacement current in case of capacitance? In case of capacitance, there is a capacitance, right? And let's say this is the A and this is the B end, and there is in between there is a dielectric, and the current is not, the circuits are not connected directly. Still the current is flowing. That why? Because the displacement of current, and see the current density, amount of current is passing for unit area. So these are the things we just have to notice it out. Okay, so these are the four scenario. I differential form I have discussed, and in the next step I will discuss about the integral form. Okay, so to realize those equations. Okay, in the next video we'll discuss about the derivation. In the next step I will discuss about the integral form of these equations. Okay, I just erase these scenarios. Okay. equation integral form we will discuss here in the integral form. Integral form of this equation. Okay, the first equation will be surface integration of d dot ds. D dot ds is equal to volume integral of rho dv. Okay, so this is the first equation, and the second integral equation is surface integral of b dot ds. B dot ds is equal to 0. So this is the first equation, and this is the second equation. This is the first integral form of the equation. This is the second integral form of equation. And the third equation is linear integral of b dot dl is equal to minus d upon dt upon surface integral of b dot ds. Okay, dl come when linear integral, ds come when surface integral. Okay, the fourth equation, the fourth equation is about like the linear integral of h dot dl is equal to the surface integral of the whole total j plus jd upon divert d upon divert t multiplied by ds. So these are the four equations in the integral form, and we'll discuss about the derivation in the next video. So till that, what is your duty right now? So you just have to analyze, or you can say, if you take more intense, then you can took the help of various books, right? So there is a books of H.C. Verma I have, that is the books that classical electromagnetism. If the basics are not understood to you, then you can took this book. I mean, it is a good book. I can say classical electromagnetism. You can understand very much betterly about the electromagnetism. So right, the first equation is about charges and electric fields, Gauss law, electric potential energy. Otherwise, the basics are also in the class 11th and 12th. All right. So these are the first video. You can say it is about the intro of electromagnetic field theory of what James Clerk Maxwell. So here I conclude my video by saying thanks you for watching this video, and I add it that please subscribe this channel and share this channel. Okay, thank you.